Okay, let's get started. This device uses just 3 electrodes. You have here the description in the setup. When you see setting up the processor, you have 3 devices, 3 electrodes. The reference electrode, this is the electrode which is an electrochemical device which uses an enzymatic reaction. Okay. How it works? Okay, we have what working electrode. This is the main part. Okay. This is, you see, here is located the enzyme. In the basis, in this basis, on top of this working electrode is located the enzyme, a specific enzyme to react in contact with histamine, and not with any other parameter. Okay. In this surface, in the enzyme gets in contact with histamine, and a reduction oxidation process appears. This reduction oxidation process will make a flow of electrons appear. There will be a difference in the flow of electrons from the moment that when there was not histamine at the moment after adding the histamine. No? Well, this is the working electrode with the histamine. You have to dry it properly. It's very simple. You put it here inside and just squeeze just a little bit the screw. This is the first electrode inside. And this is the reference electrode. It will introduce the flow of electrons in the device to be measured. Okay, and this must be screwed here. This is not necessary. This is not necessary to take it out. Can be yes, can be standard. Just has the precaution of cover it. He should be stored in darkness conditions. Oh. Yes, in darkness conditions. That's it. And normally we supply with this cover. This cover. Yes, and inside the cover must be one liquid. This is storage liquid. Is this? Is one KCl. Okay. You just put a bit of this inside. Cover the electrode, and it's as simple as that. And the other, the working electrode, where the enzyme is located, after every day, put it in its package, to the fridge. In dry conditions, we supply the working electrode in dry conditions and with vacuum. Okay, like this. In dry. There is a silica ball inside to keep it dry, and when you open it, remove the ball of silica and just hydrate it. And from the moment it's hydrated, can last 2 weeks, 15 days. You have 15 days to use it. Okay. Now this was hydrated in Spain. Therefore, it's perfect to be used. Reference electrode, working electrode of biotest. We call it biotest, where is the enzyme. And now, these are the 2 main accessories to use it. Reagents. We just use 3 reagents, no more. The self-working electrode, where the enzyme is located. Measurement solution. This measurement solution is provided by us. Each one of these tubes is valid for 1 liter. It must be mixed in 1 liter of distilled water. And the purposes of this reagent is supply a comfortable buffer with a suitable pH to the enzyme. It's comfortable. Working comfortably. This is basically a buffer.
Right.
We put always. Sorry, I need 10 milliliters always. Okay. we always put 10 milliliters of measurement solution in the cuvette. That's all. This is 1 liter of distilled water mixed with one of these tubes. Biotest with the enzyme, measurement solution, and the third and last reagent is calibration reagent. The calibration reagent are supplied in dry conditions. This is 1 tube, and with them we have to add 10 milliliters of histamine measurement solution, this, to prepare the calibration reagent. This is valid for 3 days and must be kept on the fridge. In the fridge, the biotest with the enzyme and the calibration reagent on the fridge. 15 days after hydration, and this 3 days. 3 days. I have here one of these tubes already prepared. Now I have prepared it before. This is already hydrated with 10 milliliters of measurement solution. And with this, with the calibration reagent, we can call it as calibration reagent mother. We prepare the calibration standard, with the standard of calibration, the son. It is needed to prepare it every day. It's very simple. We have to just add 19.9 milliliters of, again, measurement solution, and 100 microliters of the calibration reagent, nothing else. Well, now, first of all, let me prepare this just to waste the water. Well, normally. Okay, just to prepare it. First of all, while the device goes ahead with the activation and calibration, after that we will prepare this. But now I'm going to show you again. After explaining the 2 electrodes and the 3 reagents, let's see how the device works. Okay, we can use it. Basically, normally we should switch it on. Okay, we mount the reference electrode, the working electrode. We can switch it on. 2 seconds, pressing the button, it starts. Okay, biotest. Histamine sulfite, histamine. Choose. This is the code of the biotest that is printed here. If we want to change a new biotest, we have to write down the code. The device will know the number of analyses on the, okay, we will detect the biotest. In this case, we've made 3 analyses and we have 47 analyses more. Okay? Okay, we go ahead. Fish meal, salted fish. In this case, fish. Okay? Now the biotest is already set up. Now let's go to analysis. Normally we have one activation process that is just to wake up the enzyme. The first moment of the day, after taking out the working electrode, the enzyme from the fridge, it's an enzyme, it's an alive. It's necessary to wake it up. It's with activation. Here we're going to see how the enzyme is waking up, because there is a small flow of electrons, and we will see here in the laptop how the intensity signal is acting. No? What we see here with this graph, it's this value of intensity we are seeing. It's not necessary to the laptop, but it's highly advisable, because if you have a laptop connected and if you find any problem, you find out something is working wrongly, okay, you can print the screen and you can send it by email to us, and we and our headquarters, our laboratory people can help you, can give you support. Okay, we are finding something different, something is working not, we guess something is wrong, you send us a, okay. Well, as I'm in already in my room working with the working electrode, now it's not necessary to carry out an activation. Okay, because the enzyme is already wake up. Okay, we can jump this step. Calibration. Okay, the calibration is necessary to prepare every day the standard of calibration, and it's very simple. We have to add 20 milliliters, well, 19.9 milliliters of measurement solution, 100 microliters of histamine calibration. Well, what we do normally is we add 20 milliliters, remove 100 microliters, and after that we add in this quantity that we have already removed, okay, 5, 10, 15, and okay, 20. And now we just remove. It's important to be accurate here, okay? We just remove 100 microliters. Now we have here 19.9. We have just have here the same quantity of the calibration reagent. That's all. We have already the standard of calibration prepared. Okay, we can proceed to the calibration process. Well, what we are going to see now is how the current reaches one stable stage, and the device, once the intensity is stable, asks us the device, okay, add 2 milliliters of standard of calibration. We add 2 milliliters, and in that moment, here this liquid has a concentration of histamine. The enzyme will detect this concentration, and you'll see a change in the current, a jump, as a consequence of the histamine addiction. When a second stable stage has been reached, the device will ask, okay, a second addiction, please. We will add the same, 2 milliliters of the same standard of calibration, and a second jump will occur. And after the second jump, we will have 3 points. The 0 point, the first stable condition, and the second stable condition. 3 points will perform one line of calibration. This line of this slope of calibration will be the slope which will relate the intensity with the histamine concentration from now on. Okay, for the whole day. And we need 2 milliliters. And the quantity to add now is the same. 2 milliliters of standard of calibration, 2 times. And after the calibration process, in the sampling procedure, is the same. 2 milliliters of the extraction. You'll see how the current is quite stable. Normally, the device doesn't finish the time. If the current is stable enough, normally he will ask to make the addiction before. It depends on the stability of the signal. Okay, press continue and add 2 milliliters of standard. It's important to press continue, and after pressing, make the addiction, because in this moment the device is detecting the 0, and now he will detect a change in the conditions.
Okay.
Now I'm going to make a zoom here. Focus. Look. This is the reason why the device has wasted time, because the signal, the signal of the current is not very stable.
Right.
Well, you see, in this moment we made the addiction.
Right.
There is a jump. Okay. Probably this noise, this electrical noise, is due to the fact that we have not carried out to make it quicker. We have not we didn't the activation, the first stage of activation that we have passed. Okay. Now you see how the second in the second leap the current is more stable. Now it's becoming, is coming the third jump. Look all the time with a non-stable signal, and with a stable signal, the time is half. This is time, and this is intensity. Intensity in nanoamperes. This is the same, 679 nanoamperes. Okay, calibration complete. The device is complete. The device is calibrated. Now we can proceed to carry out one analysis, 1, 2, or as much analysis as we want. Okay. I prepare now in the bathroom. Yes, to any time. You have here 10 grams of smashed and homogenized fish. Okay, it's a kind of.
From lunch?
Sorry?
That's from lunch? That's our fish from lunch?
No. No. It's a kind of fish that I brought from Spain. Okay. You have here R. The R is the precision of the R tells us how good is the line of calibration. It's a linear regression. Okay? And M is the second parameter. Is very important because it tells us how is the slope of the line. It must be at least 0.999, and the M must be above 150,000. Two conditions are met, no problem. Then, now we can go ahead with the sample. To the range. Okay. The cuvette on a stand, it's very important to change the cuvette. Okay. To carry out one extraction, we need 10 grams of fish, and in this range from 5 to 50, 10 grams of fish, 40 milliliters of distilled water. I think more or less, yes. You can do it with measurement solution or with distilled water. It's the same, okay? I use the measurement solution because I have here the distilled water. Or you can use anything, any of them. Once it's closed, the extraction is like this. So easy. Now once we leave it rest, And normally the solid part will go down and we have to extract just the liquid, that's all. Okay.
Did it say how long? Did I say for that?
I should have shaken it more, but maybe 10 seconds, 15 seconds, but
Okay.
it was not.
Between for raw fish, we have to use it like that.
I said that I should have moved it more, shake it more, but it had a leak. And
Oh man.
yes, I prefer to, you know. Okay.
If we use a blender to do this thing with the raw fish, we have to filter it
The blender.
through filter paper. It says here, in the case of raw fish, an extra blend instead using a homologizer or a hand blender is recommended.
Yes, it's recommended. It's not necessary, but it's
So
recommended.
after we finish doing that, we can filter it.
Feel?
Filter using filter paper.
Depending on the shape of the can.
Okay.
If you use one narrow and long normally and shake it after mixing, shake it,
Mhm.
normally you will have enough part of liquid
Okay.
to pipe it without problems.
Alright.
Yes, normally, well, it's just to get used to
Okay.
use the pipette. Press continue and make the addiction. After making the addiction, you see a very small peak. It will give us very soon because now the current is very stable
Mhm.
and the answer will be very, very quick. Should be very quick. Seven. Okay, and now you can save it. For instance, sample 5. Okay, save it, and it's saved in this sample is stored in the device.
Okay.
And with this software, you can download to an Excel sheet.
Okay.
Okay. Now, after make the calibration, everything is already done, and it's so we see as follows. So we see as follows. As I said. Okay, we just yes, and one after other, and now it's very fast. You can have, while the calibration process is carried out, you can prepare 3, 4, 5 samples, as samples as you need. You shake them and you just let them rest.
Oh, okay.
And after the calibration is made, it takes more or less 10 minutes, 15 minutes. You can measure every 2-3 minutes, one after other. It's very fast, and as you see, it's very simple. The reagents are not toxic at all, not for the human beings, not for the environment. They can be wasted by the, as I said during the. I wanted just to show you this basic introduction, just to give you a briefing before of tomorrow's workshop. Because tomorrow, in this way, tomorrow, the workshop won't be new for you. At least, and if you, I don't know, if you find out any kind of doubt, any possible problem that you can find, you can ask for it tomorrow. And you have a storage recommendation for the reference electrode, the biotest. Okay, it's very short manual, but it's very clear because the device is very simple. Therefore, it's not necessary. Well, a deep explanation. It's very well. Okay. As we made everything very fast, and normally it's recommended to let the samples rest a couple of minutes, a minute before off. Well, therefore we can find any possible difference, no? But because I mean that probably this sample can be other result. Normally we should have let it 2-3 minutes just to extract all the 4-7. Normally the device has an error at 10%. If it gives you 20, it can be 22, 18. This range normally. 7, 4. Well, you know. And if we make another analysis, we will have a sample. Oops. Sample 6. That's all. Okay. Now, if we go to records, histamine, you can see 1, 6, no, 2, 5, sample 4, sample 3. These are samples I made in the room before to try to put in the device. Okay, this is the basic functionality of the device. Take into account 3 reagent measurement solution. It's for everything. It's for everything. It's used as well to hydrate the biotest with the enzyme. Measurement solution, calibration reagent, and the biotest. That's all. And the storage recommendations are in the manual. There is another software that you have here in the pen drive. You have graphic Biolan, is the software to see the graphic, and software Biofish. Software Biofish is the software which will allow you to download the device. Okay, connect, 3. Okay, you have a green point here, it's connected. Now, data. Download data from the device. No more analysis, you have here the result and the calibration figures. Therefore, you can see if the calibration was fine or not, according to the recommendation in the manual of how must be a calibration, and sample, the number, and the results of the sample. Therefore, and now you can save in Excel. And the device are in Excel. The software can gives you the possibility to make a report. You can configure a report. For instance, you can put here your logo. You can put here, you can write down here standard text, and after you can see here the analytical result. That's all. It's configurable, no problem. And well, basically, it's as easy as this.